right, class. Is it audible to all of you? Akifa, you've joined this class. Your exams are over, Akifa. Yes. Am I audible to all of you? Or hello, class. Hamza, you able to hear? Okay, two more left. Okay, I'm audible to us. So at least respond, no, class. Nobody is unmuting. Everyone is typing. So how will I know? Akifa, didn't you get the notice to join the other batch, Monday, Wednesday batch? Any information you got from our side to join Monday, Wednesday batch, Akifa? No. So Akifa, are you available on Monday and Wednesday from 9 to 11? 9 to 11 means IST. So it will be 7:30, I think, for all of you. So 7:30, Monday, Wednesday. Are you free? I think you don't have any other class. Because that batch is better for you. Let me know, Akifa. I'll text you otherwise. Okay. So class, let us just start with the revision of electrostatic potential and capacitance. So electric potential was electric potential is exactly what you have studied for potential from one to another point. When we talked about electric potential energy, we brought in one point from infinity to a respective point. Now we are just bringing one point to another point. So the entire work done to bring a charge, a test charge from a point to another point, we call that quantity as electric potential. One of the best way to solve this is by just adding it, because this is a scalar quantity. Fine, class, it is a scalar quantity. We were studying Coulomb's law in the last class. What did we study? Q1, Q2 had to be present. Right, Q1, Q2 had to be present. Kulsum is present. Kulsum, are you able to hear Kulsum? Kulsum, same thing. Will you be able to join Monday, Wednesday batch? Are you available on Monday, Wednesday? Same timings, 9 to 11 IST. So I think that means 7:30 for all of you.
I can't, ma'am. I have other classes.
I
have other classes, ma'am. I cannot join on Monday or Wednesday.
Okay. You have other classes. I just wanted to. It's fine. Okay. So yes, I was saying property of a single charge. So it is the potential difference between 2 points. When this potential difference, the total work done to bring a property of when we, but the charges have to be present to exert force. But when we're talking about electric field, when we're talking about potential, even a single charge will generate its own potential, its own electric field. So these are quantities of single charge. Having a single charge enough. And the potential is given by the Q by R, you have to remember. So force. Okay, voice is lagging in between. Please let me know. Is it fine now? If it keeps on lagging, no, just let me. I'm having internet issues today. Just let me know if it is. Okay. See, class, this, if you remember this part, know that F is equal to KQ square by R square. ठीक है, ये force है. Force का formula है KQ square by R square. लेकिन as you come into electric field's formula is KQ by R square. Means delete one Q. And when you come to potential, you are just left with KQ by R. Rest of the thing, whatever we have studied for force, that will remain same. Understood? Same thing. It will remain it will remain as it is. It will remain same. Why will it remain same? Epsilon, permittivity of free space. So these things will remain same. See, and for electric, when we had electric field and electric force, every quantity, individual quantity vectoric laws, no need to apply, or parallelogram law, triangle law, polygon law, any law you do not have to apply. So electric potential is this total electric potential. So these were some questions we did it in the class. Let us practice one question from this topic as well. I'm writing down the question, note it down, try to solve it. See class, more than a question, no. The question that have come in your previous years is that nature of the potential in comparison with electrostatic. Like electrostatic potential is there and electrostatic field is there, so it's variation with R. See, if electric field, if you notice over here, and potential also proportional. This is so if I am so if we plot a graph, if you plot a graph, a single graph, if you plot between E, various quantities, you have to see electrostatic potential and electric field with respect to R. So see, how will you draw? See, for let's say this is potential. One graph I have drawn. This is, let's say, potential. This graph is depicting potential KQ by R. Okay. Now I'm taking on the other side, I have taken electric field. You will notice electric field graph is a little steeper than the graph of potential. This is the difference that will arise. E is equal to KQ by R square. Same things, because E is inversely proportional to R square and V is inversely proportional to R. Am I audible to all of you? Class, note this down. Let me fix my internet once again. Note it down. The graph, this graph can be asked to you in the exam. Now check, is it audible to all of you? Screen is sharing with you. Yes or no? In this graph, both quantities are inversely proportional to R. So how will we decide? If you have to plot both the quantities on the same graph, how will you plot it? So the method to plot it is that we have plotted both inversely proportional. Inverse square rule we have applied. Now what it is coming, that if both formulas are slightly even different, there should be a difference in the graph. So you will draw a steeper graph for electric field while it will be a narrower graph for potential. This will just be the difference. And you will get question in the exam to draw the variation of potential and electric field. And it will mention you something from of a point charge from R like this. So plot this graph and do mention this fact that electric field graph is steeper. Is this clear now? Okay. So just write it, class, then I'll start with the next topic. Of a dipole, this will come to you, potential of a dipole. If it comes to draw and write the derivation of equatorial and axial field, no, first show all this derivation, this entire derivation you have to show it for the general case. This is not an axial or equatorial point, P point that I have taken over here in this diagram. This is just a general case. Okay, you will just write it, draw it, and then once done, then you will, after getting this formula kp cos theta by r square minus a square cos square theta, or when you apply ideal dipole approximation, this is kp cos theta by r square, then you will show that for axial field theta is 0, so kp by r square it becomes. And for equatorial line, potential is 0. And class, from equatorial line, you get your conceptual questions also in the board examination. That what is the value of potential in equatorial line, and some theory question like this, who is just to write that potential is 0 at the axial point. So general case also you have to remember, and in the derivation you have to show that also. Now class, this is the most important formula, though it's a very short, very small and easy formula, but it has a greater significance. And the just 2-line derivations is there, but you have to write down the derivation along with those 2 important points which I had mentioned to you. Remember, one important point was that electric field is actually proportional to potential gradient. Potential gradient means change in potential with respect to position. This is what I have written here. So change in potential with respect to gradient, that I have here written. Same thing here. Now see, electric field first point is directly proportional to change in potential with respect to position. That is, it is directly proportional to gradient. Second important thing that you have to write down is that electric fields, this negative sign that is arising in this formula here, this negative sign which you are seeing in this formula, this negative sign here, this is just because that this negative sign is just because it is showing you that electric field decreases where the potential increases. Electric field decreases in the direction of potential. These two importance are very important conclusion facts, and they have come a lot in your previous year's paper. Just go through the paper, you will see this question has come in the theory part. So E is equal to minus dV by dr, this formula. Partial derivation is not very important from your board examination perspective. Partial derivation is not that very much important, but you have questions from this topic. One question numerical, I am writing it down. Note it along with me. Center of a square of side root 2 meters having all these four charges 100 microcoulomb, minus 50 microcoulomb, 20 microcoulombs, and 60 microcoulombs at the four corners of a square. Fine. Now see, let me just draw the square first. So it is having side root 2 meters. So this will also be root 2 meters. This will also be root 2 meters. This will also be root 2 meters. Now we have to find out electric potential at the center of it. Fine, center of it. So if you have to find it at the center, then you also have to know the separation between this point. this diagonal, this part of the diagonal, this part of the diagonal, and this part of the diagonal. So if you know the diagonal, you can divide it by 2 and get the half portion of it. So see, if this is root 2, apply Pythagoras theorem. So diagonal will be root 2 whole square plus root 2 whole square. This whole with an under root. So root 2 into root 2, that will become 2. And plus root 2 into root 2 will become 2. So 2 plus 2 under root, that is root 4, means 2. Now when you take the, let's say this separation is R. All these separations, let me take it as R. So R will be diagonal divided by 2. So that becomes 2 divided by 2, which is 1 meter. Now you know the R that we put in the formula is 1 meters. Okay, one charge was here 100 microcoulomb. So when I write the potential, this will be KQ by R, we write. So KQ1 by R plus KQ2 by R plus KQ3 by R plus KQ4 by R. Now from here, K by R, if I take common, I'll be left with sum of all the charges plus Q3 plus Q4. So if you write down the values, K is 9 into 10 to the power 9, R is 1. Now first charge, 100 microcoulomb. So 100, let's take 10 to the power minus 6 also. We'll take 10 to the power minus 6 common. So 100 microcoulomb, then minus 50 microcoulomb. Then we had 20 microcoulomb and 60 microcoulomb. Then micro, we can write it as at the end 10 to the power minus 6. So 100 minus 50, 50, 60, 70, 70 minus 60, 10. So that is 9 into 10 to the power 9 into 10 into 10 to the power minus 6. So 3 plus 1, 4. 9 into 10 to the power 4 volt. This is the total voltage. Okay, note it down. Okay, class. Next, Hanifa, I hope you have seen the question, or you want me to scroll it back, then let me know. I'll shift the page.
No, sir. No, ma'am.
Okay, just a second. Okay, next is equipotential surface. So surface at the type of surface where at every point the potential is same. So let's say a sphere is there. So at every point of the sphere, you take this point A, you take this point B, you take this point C, you're getting 2 volt only. So that means this is an equipotential surface. And this necessarily needs not to be a sphere. It can be any irregular random shape. Now, when you are asked to write about equipotential surfaces, along with the definition, you'll have to mention the properties by yourself only. Fine. So first property is because of the definition only, which includes potential at every point on the equipotential surface is same. This you have to mention. Now see, second one is work done is charge multiplied by the change in potential. Charge multiplied by the change in potential. So work done, change in potential is 0 because potential is not changing. That is the whole point, because in equipotential surface, all the potential is same. So work done will be 0 because work done is change in the potential multiplied by charge. An electric field is perpendicular to the equipotential surface. Fine. Equipotential surface, electric field will always be perpendicular to it. And now see, in the regions where equipotential surfaces are closer, that depicts stronger electric field. Fine. And where equipotential surfaces are located distantly, that shows weaker electric field. Now, these are usually not asked in the exam. Mainly your equipotential surface is asked. So isolated point charge can be asked to you. Just a second, class. Okay, now isolated point charge can be asked. So these topic, no, this isolated point charge, two charges, dipole, these are usually not asked in the exam to draw. But if it is asked, then you will draw exactly like this. But mainly from this topic, no, you have to write about the definition and then you have to write about all the properties of equipotential surface. Now, electric potential energy. This is a very important topic. Potential energy means when you are bringing a charge from infinity to their respective position. And potential was what? Potential was when you were bringing charge from one point to another. That was electric potential. Potential energy when you were bringing a charge from infinity to its respective position. Now, when a potential energy of a system of two charges, this derivation will be asked to you. So you have to perform for two charges only it will come. For n charges, it is usually not asked in the examination. So this is more important than the next derivation. So potential energy of 2-point charges. Fine. So potential energy of a system of charges, where you have to show that when you have brought in the first charge and then you have brought in the second charge, what is the work done? All the entire work done gets added and converts itself in the form of potential energy. Okay. Now, potential energy of n charges, n number of charges you will keep on adding and you will get the same result. One more thing, this point, class when potential energy is negative, that shows your system is bounded. System is intact, attractive forces exist. But when your potential energy is positive, that shows system is unbounded. It means your system is unstable. So positive, go for and we prefer the negative potential energy. And work done to make the system is exactly negative of the work done to break the system. So by just getting the answers of potential energy, you will get the answers of why work done to make the system, work done to break the system. Now potential energy of electric dipole. Torque is P cross E, that is PE sine theta. P is the dipole moment, which we discussed in the last class. The dipole moment formula is what? The magnitude of one of the charges with the multiplied by the separation between them. And E is the electric field. So PE sine theta. All right, this formula is important from electric field. Now, using this formula, you will get the value of work done and potential energy. So work done is minus PE cos theta 2 minus cos theta 1. And potential energy, this is work done. This gets stored in the form of potential energy. So exactly answer of potential energy is this only. But if you know that one of the angles is 90 degrees, then you can directly use minus PE cos theta. Otherwise, use properly minus PE cos theta 2 minus cos theta 1. Else write PE cos theta 1 minus cos theta 2. If you are using negative sign, then put cos theta 2 minus cos theta 1. If you are omitting this negative sign, you can write simply PE cos theta 2 minus cos theta 1 minus cos theta 2. This part is asked not only from your theory questions. This is asked from your conceptual questions that you have. So if the angle between electric, it will be asked to you like if dipole and electric field are aligned together, then what is the maximum, or when do you get the maximum value of potential energy? What is the angle that is necessary to bring up the potential energy zero? Like these, you will be having questions. So all the answers will be hiding over here only at this particular concept. Fine, let's practice questions from this topic. This is an important topic here. Potential energy as well as dipole. 2 centimeter. So length means 2a. So this is 2 centimeter. That means 2 into 10 to the power minus 2 meters. Fine. Or 0.02 meter. This is placed with its axis making an angle of 60 degree to a uniform electric field. So here theta is 60 degree to a uniform electric field of 10 to the power 5 Newton per coulomb, and it experiences a torque 8 root 3 Newton meter. You have to find out in the first part the magnitude of charge on dipole. So see, formula of torque is P E sine theta, and if you write the formula of P, that makes it 2A into charge into E into sine theta. See, only this is unknown. Rest of the things are known to us. So torque is 8 root 3 is equal to 0.02 into Q into 10 to the power 5 into sine 60 degree. So sine 60 degree will itself be root 3. So 8 root 3 is equal to 0.02 into Q into 10 to the power 5 into root 3 by 2. Root 3 gets cancelled. This 2 will cancel, the 0.01 will be left. So answer will be 8 into 10 to the power minus 3. So charge will be 8 into 10 to the power minus 3 coulombs. Second part says that potential energy of the dipole. See, potential energy is minus PE cos theta. So minus PE cos theta. Now again minus Q. Now you have the value of Q from this part. So from here you will insert Q PE cos theta you will put. So 8 minus 8 into 10 to the power minus 3, 2a is 0.02. Electric field is 10 to the power 5 and cos 60 degree, that is half. So this will become minus 8 only will be left. No? So minus 8 joule, this will be the answer. And here answer is okay, noted. Any doubts you have, let me know. Okay, let's start. So this completes your electrostatic part. So you have capacitance. Now let's complete capacitance also. Now, the ability to store charges is known as capacitance. That ability is known as capacitance. But the device that stores the charges, that is known as a capacitor. Fine. Now, capacitance formula is charge divided by the potential. C is equal to Q by V. SI unit can be written as 1 coulomb by 1 volt. But we have a specific unit for it, which is known as farad. Fine. This is known as farad. So electrical capacitance of a conductor is the measure of its ability to hold the charge. So when an insulated conductor is given some charge, it acquires a certain potential. So if we increase the charge on the conductor, potential also increases. And if a charge is put on an insulated conductor, it increases the potential. That's why we get this formula. We actually have this formula as Q directly proportional to V. From there, the constant term is known as C, which is the capacitance. So 1 farad is the SI unit. 1 farad, if the addition of one charge of 1 coulomb is there, then potential increases by 1 volt. Simple definition of it. And one more thing, class, capacitance does depend upon some quantities. It depends on the size and the shape of conductor. It depends upon the nature, that is the permittivity of the surrounding medium, as well as it depends on the presence of other conductors in the neighborhood. All right, this is about electric capacitance of conductor. What is the most important topic from the introductory part is the capacitance of an isolated spherical conductor. I think we discussed it in the class. Yes, this part, capacitance of conducting sphere. V is equal to KQ by R. From here, if you put in the value for capacitance of a sphere, that becomes 4 pi epsilon naught R. Now, absolute permittivity's values remain same, 4 pi epsilon naught R. Epsilon is equal to K times epsilon naught. All right. So, yes, if you put in all the values of it, for if you think Earth is a conducting sphere, so you will have to mention 4 into 3.14 into the value of epsilon naught into the radius of Earth. When you put all these values, you get the term 711 microfarad. Now see class, in this, from this part, when you are asked to write the capacitance of an isolated spherical capacitor in your exam, till here, first you will mention till this formula 4 pi epsilon naught R, this formula you will mention, and then this final 711 microfarad. Till here you have to mention if it is for a 3-marker question, because by just writing very few words you will be losing upon marks. Like for 3-marker question, you will be just getting 2 marks. Then a capacitor is a device that is used to store the charges. Two conductors having opposite charges are there, and with dielectric as the medium in between it. So from this, don't revise spherical capacitors or cylindrical capacitors in detail. After you have completed your course, entire syllabus is over, you are performing revision, then you can glance through cylindrical and spherical. Otherwise, most important topic for you all is parallel plate capacitors. And all the derivations that we did, all these derivations that we have done are very important. Now, a summary of it is this. If both the plates are completely filled by air, that is, you have not put in anything in between by yourself, so capacitance formula is epsilon naught A divided by D. If you completely fill it with dielectric, then multiply it K with K, that is the dielectric constant, or you can say multiply K with the capacitance in air. Then you have partially filled dielectric. So if you have partially filled dielectric, you'll put it as epsilon naught A divided by D minus T plus T by K. So here T is the thickness of the slab. And C is equal to epsilon naught A divided by D minus T when you have partially filled conductor. So difficult task is to identify which case. Because if you identify the wrong case, you will be using the inappropriate formula and will be resulting or landing onto a different wrong answer. So completely filled air, completely filled dielectric, partially filled dielectric, and partially filled conductor. All these four cases are separate, and be sure of whatever case is given to you, whatever case is the question hinting to you. Examiner will not give you marks if you have substituted the formula of completely filled dielectric in the place of partially filled conductor. So be precise regarding these formulas. Rest questions, difficult questions won't be asked from this topic. Simply formula-based questions will be asked. So that's why I'm saying prepare for it well. Prepare for this part well. Do it correctly. Learn the formula. Learn the derivation. From here, derivation can also be asked to you in your exam. So derivation along with the formula, and then that is enough. And just identification of which case is this. Then energy stored in a capacitor, this derivation is also again important. From here in the exam, mention one of the formula. Let's say you will land up to U is equal to half CV square, or you have landed up to Q square by 2C. So do show the conversion and show that this formula, same formula, can be written in two manners. So half Q square by C, half QV, or half CV square, any of these three will be used depending on which type of numerical you have. And class, whenever you are coming, do practice the numericals, and then firstly do revise the theory part and do all the numericals that we have practiced in the class already. Now it says you have to calculate force between the plates of capacitor. So we did it in the form of a question, but class, this can be asked to you in the form of derivation also, the same exact question, or it can be asked to you in the form of numerical also, where the values of charge, the values of area of the plate will be mentioned to you, and you have to calculate the force. So this question, as well as the next question, that is calculate energy density between the plates of a capacitor, that is also ultimately that is also important. Now see, energy density and same thing, force. Here you will be given the values. You can directly be asked to calculate the final answer. So don't take these two questions as separate class questions that we did, and do not mix and confuse it with the other types of question that we have done. These two questions are in the form of derivations that we had completed. So remember these formulas as well, especially for energy density more than force. Force also questions are there in your board exams that have come from force between two parallel plate conductors. Now potential energy is half E square into epsilon naught. Remember this because you can relate it to magnetics. In magnetics, you have the formula half B square divided by mu naught. So that also will be helpful. Now, sharing of capacitors is a good topic, and this is very easy. Just the derivation looks lengthy, but you will be able to manage. You just have to conserve all the charges that were total charge that was present before sharing, and the total charge that was present after sharing. Fine, so charge before sharing and charge after sharing. So common potential you have to write down. Common potential is C1 V1 plus C2 V2 by C1 plus C2. Common potential derivation is very easy. So this you can remember on your fingertips. But class, numericals are there on common potential as well as numericals are there on the lost energy. So this loss in energy is also asked. C1 C2 V1 minus V2 whole square plus C1 plus C2. So this is the loss in energy which you have to remember. If you put a negative sign here, then you have to change these signs as well. V2 minus V1 whole square. So both the formulas are appropriate regarding the question that will be asked to you. Fine. So loss of energy, sharing of capacitors. Now tell me class one thing. Till here, any doubts you have? Is it clear to all of you? Others also who have not responded till now. Huzefa, Hiba, Sara, are you people able to understand? Rishan, Akifa, Hamza. Okay, good then. Let's practice some numericals from the capacitor. charge 1 nanocoulomb are at a potential of 900 volt each. Now it says all these drops combine together to form a single large drop, and you have to calculate the potential of this large drop. So C class, capacitance of each small drop is given. Let's say all the capacitance is directly proportional to the radius. So let's say a constant term is there, Kr, C is equal to Kr. Now this is charge on each, this is the capacitance of each small drop. This is capacitance of each small drop. So charge on each small drop will be Q is equal to what? CV. So that will be Kr into V, and potential is 900. This is charge on each small drop. This is the charge on each small drop. So charge on the larger drop that we have to find out. This charge on the larger drop. This will be actually this, see, 8 identical are joining. It means the total charge on the large drop will be 8 times the charge on a single small drop. 8 times, no, it has enhanced. So Q prime will be 8 times the charge on smaller, that is 8 into this entire term, Kr into 900, which is 7200 Kr into C. This is charge on larger drop, charge on the larger drop. Now volume of the large drop, see, volume will be conserved, volume will be conserved only. Diameter is changing, radius is changing, but volume of the drop, the amount of water that is involved in the formation of one single drop, that will be same. You will have same. So volume of large drop will be equal to volume of 8 small drops. So volume will be 4 by 3 pi capital R cube. This is equal to 8 into 4 by 3 pi small r cube. 4 by 4 by 3 cancels. R becomes 2 small r. This capital R becomes 2 times small r. So now the potential. The potential on larger drop. Will be charge on larger drop divided by capacitance. So this is 7220 Kr, and capacitance we have taken it as 2 Kr. So potential will be 3600 volts. Note it down. Any doubts? Ask me. Clear itself right here. Then one small topic we'll do, and then I'll finish with the class. Note it down. Now see class, at the last we have the combination of series and parallel capacitors. If the capacitors are connected in series, then we reciprocally add the capacitances values, and if they are connected in parallel, we simply add it algebraically, like 1 plus 2 plus 3 plus 4, like this. So that was all about the theory part. Just one numerical is left to be discussed, then I'll leave you all. So this is a question which involves the combination of capacitors. Now, last question is it from this lesson. So please try to respond in this properly. See class, all these three are connected in series or parallel. Yes, series or parallel. Parallel. No, Hamza, see these three, no, the wires have just turned like this. This is a straight same wire that has turned itself. Fine. So if it is turned, we'll say if when until and unless you observe branching, then only you will be writing it as parallel. Since they are connected straight away with the help of straight wire, you will be writing all these three are connected in series, and in series we reciprocally added. So 1 by 60 plus 1 by 60 plus 1 by 60. Now, one more thing I have told you, if identical combination is there in parallel, simply divide the number by number of capacitors. So 60 by 3 will be 20 microfarad. Now see how the circuit will look. So here was the 40 microfarad one. Here you had the 10 microfarad one. And the one that we have just found, 20 microfarad. 20 microfarad, 10 microfarad, 10 microfarad, 40 microfarad. This was A point. And here B point. Now see, Hamza, now observe. All these three are connected in parallel because here you can observe branching, here you can observe branching, here also branching, and here is also branching. So branching means they are connected in parallel. And if they are connected in parallel, then C dash will be simply sum of all these. So that will be 10 plus 10 plus 20. That will be 40 microfarad. Fine. Now let's again reduce the circuit from microfarad. So all these three have been reduced. Now we are left with what? See, this 40 microfarad was there. A point. And now also we have got this 40 microfarad. What will be the answer now, class? Yes, class, answer. Series, parallel, what combination? Series, good. So only Hamza is responding. It is series combination. So final C equivalent will be 40 divided by 2, which is 20 microfarad. This way only you have other questions as well. Note it down, text me, done in the chat column. I'll stop the class. Chapter revision is completed. Then we'll start with current electricity in the next class. Revise current electricity and come. First, note this down. And when you have completed, do text me done in the chat box. Okay then, Hamza, Heba and all those who have completed, now I'm done with the class, so you all can leave. We'll continue current electricity. And Akifa and Kulsum, if you can get time on Monday, Wednesday, do let me know. Akifa, you also Monday, Wednesday, 9 to 11 IST. That is 7:30. That batch will be better for you, Akifa.